Welcome back for the next lecture on aircraft refrigeration system. In last lecture we have discussed the simple air refrigeration cycle, simple air refrigeration system for the aircraft. Now in that simple air refrigeration system we are using one compressor, one heat exchanger, one turbine and fan. But in this next advancement we are doing some multiple use of the components. So please note the name of this system: bootstrap bootstrap air refrigeration system. Now what is the difference in the simple air refrigeration system and bootstrap air refrigeration system? In simple air refrigeration system we are using only one heat exchanger, and here we are using two heat exchanger. Also in simple air refrigeration system we have used only one compressor, and here we are using two compressors, namely primary compressor or jet compressor and secondary compressor. Now as usual the process is starting from the surrounding air. So that surrounding air is passes through the conversion section, so due to which the pressure and the kinetic velocity of the kinetic energy of that air is increases. So that high velocity, high kinetic energy air is called it as ram air. Then some amount of ram air is passes to the main compressor or jet compressor, and some amount or fraction of that ram air is passes to the bypassed for the further action. Now that rammed air which is passes through the jet compressor, so the compression action is takes place. Compression action takes place. So due to which the air becomes high pressure, high temperature air. So after compression, pressure and temperature is increases. So that high pressure, high temperature compressed air is passes to the heat exchanger 1. Here we are naming heat exchanger 1 and heat exchanger 2 because here we are using two heat exchangers. Now that compressed air, hot compressed air is passes through the heat exchanger, and for that cooling of that hot compressed air we are using that bypassed ram air. So that fraction of that bypassed ram air is used for the cooling of the hot compressed air. So that in the heat exchanger 1, heat exchanges takes place between hot compressed air and the low temperature bypassed air. So due to which the temperature of the compressed air is reduced. Now again that low temperature or moderate temperature compressed air is passes to the secondary compressor. Already in the first compressor some pressure is increases, then in the secondary compressor also some compression is takes place. Means this is the case of multi-staging. In the next chapter we will discuss what is multi-staging and all this. So just I will give a quick idea about the multi-staging. So where the pressure ratio is high, at that time we are using the multiple compressors, so that the work of compression is decreases. Means suppose we have to compress from 1 bar to 50 bar, so in one compressor it is very difficult from 1 bar to 50 bar, but if you are using the two steps of compressor from first 1 to 20 bar and second compressor 20 to 30 bar, so that the work of compression is reduced. So that compressed air is passes to the secondary compressor. So again in the secondary compressor pressure is increases, temperature is also increases, so that high pressure high temperature compressed air is passes to the heat exchanger number 2. Now here that heat through this heat exchanger number 2, that hot compressed air is the hot fluid, and also for the cooling of it we are using the bypassed ram air. Please remember, in heat exchanger number 2 the hot fluid is the output of the compressor second, and cold fluid is the bypassed ram air. So due to which the temperature of the compressor air is decreases, and again that air is passes to the turbine. Here again turbine is there, so in the turbine expansion is takes place, so the pressure and temperature of the air is reduced, and that low pressure low temperature air is passes to the aircraft cabin. That low pressure low temperature air is passes to the aircraft cabin. So that same process is shown on this TS diagram. So that ambient air pressure, cabin air pressure line, ram air pressure line, and here you will observe two compressor pressure lines are there. First line is for the jet compressor and second line for the secondary compressor pressure. So here, so from 1 to 2 the ramming is takes place, the pressure is increases, the kinetic velocity is kinetic energy and velocity is increases. Then from 2 to 3 it goes to the jet compressor, so compression takes place. Then from jet compressor it goes into the heat exchanger, and in the heat exchanger constant pressure heat rejection takes place, so that the temperature is fall down. So that is shown on the same line 3 to 4 process. The cooling is takes place up to 0.4. Now again it goes to the secondary compressor. So from 4 to 5 again compression takes place, pressure is increases, temperature is increases up to point number 5. Then it goes to the secondary compressor, second heat exchanger, where its temperature is reduces from 5 to 6, and again last it passes to the turbine, so that in the turbine pressure is reduced as well as temperature is reduces. So from 6 to 7 that process is shown by the expansion process, and again when that low pressure low temperature air is passes to the aircraft cabin, it will absorb the heat from that aircraft cabin, so that its temperature is somehow increases. So it is shown on the cabin pressure line 7 to 8 processes there, 7 to 8. So this is all about the bootstrap air refrigeration system. So generally these bootstrap air refrigeration systems are used where extremely low temperatures are required. Very low or extremely low temperatures are required. At that time we are using the bootstrap air refrigeration system. Also this bootstrap system is used for the high-speed aircrafts. So please remember the applications of the bootstrap. So it is used where the extreme low temperatures are required, and second it is used in the high speed aircrafts. So this is all about the bootstrap air refrigeration system. In the next lecture we will discuss the third method, that is the regenerative air refrigeration system.